So, what if I told you that the most powerful AI models in the world are the ones we'll never get to see? Today, we are diving into some pretty radical ideas about where AI is headed, and this is coming straight from one of the key minds behind Stable Diffusion. Let's get right into it.
Now, when you hear a statement like that, I know what you're thinking. Oh, it's just about protecting a product, right? Maximizing profit. But no, that's not it at all. The reason is actually much, much more profound. It's about a fundamental change in what these AIs can even do.
So, why all the secrecy? Well, it's because these top tier models aren't just, spitting back human knowledge anymore. They are starting to make genuine, original scientific discoveries. Think about that. The big labs aren't just hiring scientists to build the AIs, they're hiring them to work with AIs.
Okay, so that brings us to the AI that we do get to play with. It's incredibly powerful, we all know that. But there's this growing concern that its very success, the way it's designed, might actually be trapping us, locking us into one path and stopping us from finding something even better. Just think about it for a second. The AI models we use every single day, the ones built to just guess the next word, are so incredibly good and so useful that they've become the default way to do things. They're almost too good, and that success could be blinding us to other, maybe even more creative kinds of intelligence. This is a classic case of what they call technological lock-in. It's just like the QWERTY keyboard on your phone or computer. It was originally designed to be slow, to stop old-school typewriter keys from jamming. It's a totally inefficient layout, but now it's so baked into everything we do that we're stuck with it. Today's AI is kind of the same. It's locked into a design that's great at remixing what it already knows, but it really struggles to come up with something truly new. And this quote just hits the nail on the head. To make AI safe and useful, they use this process called reinforcement learning with human feedback, or RLHF. Basically, humans tell the AI good answer or bad answer. But what that does is train the AI to be, well, agreeable, conventional. It learns to avoid the weird, out there ideas. It's like you take this creative, free-thinking liberal arts mind and you force it to become a rule-following accountant. Okay, so if that's the problem, what's the solution? Well, there's a totally different way of thinking about this, called a diffusion model. Instead of guessing, these AIs learn to rebuild reality from pure chaos. And it turns out, this process is an uncanny mirror of a fundamental law of physics. So here's how it works, and it's actually pretty cool. You start with a perfect picture, right? And then you just destroy it. You systematically add random noise until there's nothing left. The AI's job isn't to guess what was there, its job is to learn the deep, underlying principle of how to put it all back together. And once it understands that principle of reconstruction, it can create brand new images or music or even whole 3D worlds, literally from nothing. And it turns out this whole process is basically a mirror of a super deep law of the universe, something called the principle of least action. It's a really simple but powerful idea. Nature is efficient, it's lazy. A river flowing to the ocean will always carve the path of least resistance. Light, traveling from one point to another, will always take the fastest possible route. Nature always finds the most optimal path. And that's the key. These diffusion AIs are learning to do the exact same thing. They're learning to find the most efficient path, the shortest path, to rebuild something from noise. In this sense, all intelligence, all cognition is really just compression. It's about finding the simplest, most elegant path from chaos to order. And the results of this are, honestly, they're kind of magical. The very first Stable Diffusion model took over 100 gigabytes of images, ran them through this whole destruction and reconstruction process, and compressed all of that understanding into a file that was just 2 gigabytes. So tiny it could run on a regular home computer and turn our words into images. Just incredible. Okay, and this whole idea of building efficient models, it's not just about AI. It applies to, well, everything. To society. If AI is really going to change the world, we need a better way to measure progress, something way smarter than just GDP, which, as you know, goes up when someone gets cancer and goes down when they're cured. So there's this new framework called MIND that offers a completely different dashboard.
So, MIND stands for Material, Intelligence, Network, and Diversity. The M, material, that's our physical stuff. It's finite. If I give you my phone, I don't have a phone anymore. But then you get to I and N, intelligence and networks. That's where things get interesting because they are generative. The more you share an idea, the more valuable it becomes. And finally, you've got D for diversity. Whether that's in an ecosystem or in a marketplace of ideas, diversity is what gives a system the strength to survive shocks.
So the core principle here is actually super simple, and it should sound familiar. The systems that win, whether we're talking about companies or even countries, are the ones that have the most accurate internal model of the outside world and can update that model the most efficiently. You could say that all our organizations are just slow, dumb AIs. All right, so if AI is getting this good at modeling the world, and organizations are basically slow AIs, where do we fit in? What's our job in this new world? What is our unique, irreplaceable role? Okay. Get ready for a pretty chilling thought. The prediction is that in just a few years, you could have teams of highly advanced AIs working on a problem where the human on the team is actually the dumbest one in the room, where our input literally slows things down and makes the final answer worse.
But, and this is a huge but, there's one thing these AI models cannot do, at least not yet. They are masters of patterns, masters of analogy, but they are not first principles thinkers, and that is something humans are uniquely good at.
So what is first principles thinking? It's the art of throwing out every single assumption. Think about Einstein. He literally pictured himself riding on a beam of light. He asked fundamental questions nobody else even thought to ask. It's about breaking a problem down to its absolute most basic truths and building your logic up from there, not just copying what's been done before. And that is our future. It's a partnership, right? Our job is to provide those flashes of human intuition, those big, weird, what-if questions that come from real curiosity. And the AI's job, to take those questions and test them at a scale and speed that we could never, ever imagine. Which brings us to our final idea. And this one's a bit of a mind-bender. As we build these new kinds of AI, it looks like we might be accidentally stumbling upon the operating system for the entire universe. The really weird thing is, the same mathematical principles just keep popping up everywhere you look. The math that describes how economies work, how energy flows in physics, how societies are structured, it all comes back to this idea of optimization, of finding the shortest path, of compression.
And now, get this. That exact same math that seems to run the universe is what's making generative AI possible. That's not just a coincidence. It suggests something really deep is going on here, that the fundamental math of reality might be the same as the fundamental math of generation.
You know, for years, physicists have kind of scratched their heads about this. They call it the unreasonable effectiveness of mathematics. Why should these abstract ideas, these numbers and equations we cook up in our heads, describe the physical world so perfectly? And so, that leaves us with this final, massive question. As we build these machines that are learning to reconstruct our reality, are they just rediscovering the universe's source code? Through AI, are we finally, after all this time, beginning to understand the fundamental logic of everything?